Hi everyone, welcome back to my channel. Today we're going to be covering how to read an electrocardiogram. So this is just a list of contents of what we're going to be covering today. But before we get started with that, I highly recommend watching my previous video on the electrical conduction of the heart, since an EKG chart is created on the basis of the conductions of the heart. And so let's get started with this list. We're going to cover what an electrocardiogram is, the difference between spikes and droops. So spikes are just like the things that go up, the lines that go up, and droops are the lines that go down. The P wave, Q wave, R wave, S wave, T wave, the PR interval, the PR segment, the QRS complex, the QT interval, and the ST segment. So what is an electrocardiogram? There are first of all two abbreviations to the word electrocardiogram. There's ECG and EKG. And EKG is an abbreviation that was created based on the German spelling of electrocardiogram. And the purpose of an electrocardiogram is to represent the intensities of the activity or the conduction going on in the heart, and conduction as in passing of signals. And so let me just quickly cover the axes of the heart. So the greater the height or the amplitude of the wave, as in up or down, the stronger the electrical activity being detected. And left to right represents time, so as time progresses, the chart will move on. And so now we know what up and down and left and right represent in this graph. So an interesting question is, why do some parts of the EKG chart spike up and then some parts droop down? So like for example here you can see that a P, R, and T wave are spiking up while the Q and S wave are drooping down. And so I'm not going to go into much detail right now, but basically when you take an EKG of a patient, right, you're going to place these sensors on their body, which are called electrodes. And these electrodes detect electrical signals of your body and of your heart. And so what happens is if the electrode detects a signal or a movement of electrical activity coming towards it, the spike is going to be upwards. And if the signal is going away from the electrode, it's going to go downwards. And so this is important because the graph going up versus it going down shows where the electrical signal is actually moving. And so we know that from the electrode and the placement of the electrode, whether the signal is going towards or away from the electrode. So the up and down of the graph shows the movement and the location of the signal at any given time. So there are three main sections to an EKG chart. There's the atrial depolarization, shown in green, which represents the atria pumping their blood into the ventricles. Then there's ventricular depolarization, shown in yellow, representing the ventricles pumping their blood. And lastly, there's ventricular repolarization, shown in blue, which is basically the ventricles resting and going back to their original phase so that they can be ready for the next pump. Now, you might be wondering, if there's a repolarization, as in resting phase for the ventricles after they depolarize, well then, shouldn't the atrial depolarization also have a repolarization phase? Well, you're absolutely right. However, when you take into account the size of the atria versus the size of the ventricles, the ventricular depolarization hides or covers the atrial repolarization, since the electrical signals of the ventricular depolarization are greater than those of the atrial repolarization. So that just makes it a little bit more easier to understand why the atrial repolarization is hidden behind the ventricular depolarization. So really quickly, let's just cover what depolarization and repolarization actually mean. Depolarization is the process of making a negatively charged cell into a positively charged cell in order to contract the cells, aka pump the blood through the chambers. And then repolarization is basically undoing depolarization so that the cells can go back to their resting phase and so that they can depolarize again. So let's just quickly recap the electrical conduction of the heart. First of all, the signal starts from the SA node, which is the natural pacemaker of the heart. And it's called this because it can make the signals, or the depolarization signals to be more specific, by itself, whereas other cells have to receive a depolarization signal to be able to depolarize. Then we have the internodal tracts, which is represented by 2.1 in the picture. And we also have the Bachmann's bundle, which is represented by 2.2. And the internodal tracts and Bachmann's bundle basically have the same function, which is to take the signal and transport it to wherever it needs to go. So the internodal tract transports the signal from the SA node to the AV node, and Bachmann's bundle transports the signal from the right atrium to the left atrium. Then we have the AV node, which just creates this delay so that the ventricles have time to fill after the atria have pumped blood into them. Because without this delay, the ventricles would not fully fill, and this would cause it to not be as good or as efficient as it could be. Next, we have 4.1, the bundle of His. So it's really tiny here, but it's that little like green thing right under 3. And so the bundle of His is basically what comes out of the AV node. And then this bundle of His basically divides into 2. It divides into the left bundle and the right bundle. And then the left bundle actually divides even further into the posterior left bundle and the anterior left bundle, because as we know, the left ventricle is much more bigger and it requires much more energy compared to the right ventricle in order to pump blood, because the left ventricle has to pump this blood throughout the whole body, whereas the right ventricle only has to pump it to the lungs. So that's why there's a posterior and anterior left bundle. Posterior just means that it's at the back, and anterior just means it's in the front. And then we have the Purkinje fibers, which is basically the left bundle and the right bundle just like going all around the ventricles to further transport the signal. And so this is just like a quick little recap. However, if you watch my video on the electrical conduction of the heart, you'll get a much more detailed and better explained version, so I highly recommend watching that. Okay, so now that we've covered all the basics, let's start with the EKG. The first thing that occurs in the EKG graph is the P wave. And so what the P wave represents is like the start of the heartbeat. The P wave shows the electrical activity that's occurring when the SA node is sending out the signal. And the signal is causing the atrial cells to depolarize, as in contract. So the P wave is basically the contraction of the atria. And the significance of the P wave is that the absence of a P wave or the size of a P wave can indicate issues within the SA node or within the heart. And if the P wave is absent or misaligned, it could indicate that the atria aren't contracting properly or the ventricles aren't filling with blood as they should. So the P wave is actually kind of crucial for the start of the heartbeat. Next, we have the Q wave, which is the first negative wave, or the first droop, as I like to call it, of the EKG chart. And so this Q wave is representing the start of the depolarization of the ventricles, because as we covered before, this middle section, which is like the QRS complex, which I'll explain later, but this middle section is the ventricular depolarization, as well as a hidden atrial repolarization. But here, what the Q wave represents is the depolarization of the interventricular septum, which is basically like the wall between the left and right ventricle. And so as this depolarizes, it starts to send out these signals to the left and right ventricles, which start the contraction. And so I would say that this is probably happening around the same time that the bundle of His, as well as the left and right bundles, are being activated. And this is just a guess from me, because the fact that the bundle of His and left and right bundles are located in the interventricular wall, I would say that the Q wave is kind of like where that section is being activated, to put it more into perspective. Next up, we have the R wave, which is like the biggest spike in the whole EKG chart. And so, what the R wave represents is like the peak of depolarization within the heart. And I would guess that the Purkinje fibers are probably at play right now, since the Purkinje fibers are responsible for the mass of the ventricles being activated. And once again, just to emphasize, this is just a guess of mine, as well as the one for the Q wave. However, I don't know if this is entirely accurate because I couldn't find any information on it anywhere. However, this just puts it a little bit more into perspective for me, since they both match up as being the creators of the mass depolarization within the ventricle. So I would guess that the R wave and the Purkinje fibers are probably being activated at the same time. But once again, that's just a guess from me. And the significance is that the R wave can indicate like issues or conditions in the heart, such as myocardial infarction, which is not a heart attack. It is actually a cardiac arrest, which is when the signal has issues getting from one part of the heart to another. And so now the S wave. It represents the minor parts of the ventricles yet to be activated or depolarized. And it's kind of like the final dust of electrical activity that occurs, and it represents the end of ventricular depolarization. And I know in this image it's shown almost as big as the R wave in terms of amplitude. However, the S wave is really just a little bit bigger than the Q wave, but other than that, it's not that big, just to clarify. And now lastly, we have the T wave, which represents the end of the EKG chart. And it's basically like the repolarization of the ventricles, which is obviously crucial in order to make sure that the ventricles can, restart this whole process of pumping blood. Now let's get into the PR interval, which represents the time that the signal takes to get from the SA node to the AV node. And if you think about it, the P wave is basically the atrial depolarization, and then the Q wave is the start of ventricular depolarization. So the ventricles can only depolarize when the signal has reached the AV node, and the atria can only depolarize when the signal has reached the SA node. So it makes sense to say that the PR interval represents the time that it takes for the signal to get past. And the significance is that if the PR interval is too short, then that could mean that there's pre-excitation within the heart, which basically just means that there are like more pathways than needed of electrical conduction, which is not a good thing. And then if it's too long, then that means that there's probably like issues with the internodal tracts, which are the tract between the SA and AV node, or that there may be an issue with the AV node itself. Next up, we have the PR segment, which is kind of like the space between the end of the P wave and the start of the Q wave. Even though it's called PR, it's more like PQ, but it's still called the PR segment. And this is one of the things that I kind of find really cool about the EKG chart, because this little segment here shows the delay created by the AV node, because at the end of the P wave, aka atrial depolarization, the signal has reached the AV node, and so this PR segment, this little amount of time, is a delay created so that the ventricles can fill. And then the Q wave is the ventricles depolarizing or contracting. And the significance of this is basically the significance of the AV node, which is basically that if it's too short, then we know that the AV node isn't creating enough of a delay. If it's too long, then the AV node is creating too much of a delay, etc. Now we have the QRS complex, which basically is this whole thing that's between Q, R, and S. So this section represents ventricular depolarization because, as we know from before, Q, R, and S are all different parts of ventricular depolarization. And now we also know that it also represents the masked atrial repolarization. And for its significance, well, other than the fact that it's what makes the ventricles contract, which is kind of the whole point, it's important because, as mentioned before, the individual parts, Q, R, and S, show different stages of the ventricular depolarization. And then misalignment or missizing, being off, can show issues within the heart. Now we have the ST segment, which is up there in the pink, and this represents the time between ventricular depolarization and then ventricular repolarization, which would be the T wave. And the significance is that if this period is too long or too short, it can indicate abnormalities within the heart, such as myocardial ischemia or infraction. Lastly, we have the QT interval, which represents the total time it takes for the ventricles to contract and then repolarize or rest. And this is important to note so that we can check to see if the patient's heart has any abnormalities or any issues. And so I know it's been repeated multiple times throughout this video, but this is exactly what the EKG chart is for. It's to see the timings of different events that are occurring in the heart, and based off those timings to see if that there are any issues or any abnormalities or anything that's improper within the heart. And so that's really the significance of the EKG chart, because it shows us all of these things in a concise way. Thank you so much for watching. I would like to just quickly thank Canva.com for helping me create this slideshow, and Microsoft Clipchamp for helping me edit this video. And I would like to thank my family and friends who supported me throughout this. And then lastly, I would like to thank you all for watching, and I hope this helped everyone understand anatomy just a little bit better.